right, let's try another Lewis picture here. And this one's going to have a little twist on it that's different. I'm going to start off with ozone, O3. So step one of doing your Lewis pictures says, let's add up the valence electrons. If we look at oxygen, each of those oxygen atoms is supposed to have 6 valence electrons, and we have 3 of those. So we're going to have a total of 6 times 3, or 18 electrons to play with in this Lewis structure. Step 2 says, put the different one in the middle. Well, they're all different. They're all the same, O. So let's just stick one of those oxygens in the middle and connect the other oxygens to it with single bonds. We just used up 4 electrons. We're going to take 4 out of our total. We've got 14 left. Step 3, fill in the octets of those outer atoms. So we're going to say 2, 4, 6, 8, 10, 12. We're going to go ahead and take away 12 valence electrons from our total. We've got 2 left over. Leftovers are supposed to go on the middle. So now we've run out of electrons. Step 5, check. Does your center have its octet? Oxygen needs an octet, and right now it only has 2, 4, 6 valence electrons. So we just need 2 more to get 8. So what do? Swipe from the rich and share with the poor. Well, we're going to swipe from one of these oxygens and share with the oxygen in the middle. But who do we swipe from? That's the question. We only need 2 more. So here's the deal. You can't draw a picture where you just swipe from the left. Let me draw it, but it's not correct. If I draw this picture alone, oxygen, swipe these ones on the left, 2, 4. Now we have a double bond with an oxygen in the middle and the oxygen on the right with 8. This picture on its own is not correct. But why? It looks like we have equal choices. Well, what if we drew it from the one on the right? What if we swipe the electrons from the oxygen on the right and share with the middle? Well, if we drew that picture, it would look like this. An oxygen on the right. The double bond is now on the right-hand side. And there's the remaining picture. Well, if we drew just that picture, it is also incorrect on its own. We really need to draw both pictures. One of them is not complete on its own. We draw both pictures and we draw a double-headed arrow in between it. The name of this particular type of picture or this particular type of circumstance is called resonance. Resonance. Now, you're not going to understand completely what resonance is until you've studied something called hybrid orbital theory and you've studied things called sigma and pi bonds. And you probably haven't studied those yet. And you will study resonance a lot when you hit organic chemistry. However, although you don't know exactly what it is yet, we should know what it is not. What resonance is not is the molecule fluctuating back and forth between these two structures. Double bond on the left, double bond on the right, double bond on the left. That's not what they see when they look at ozone. When they actually observe the ozone molecule, you don't have one short, strong bond and one long, loose, weak bond. That's not what they see. They see 2 bonds that are exactly the same strength, exactly the same length. They're a mixture between a single bond and a double bond. Each one of those is like a bond and a half. People will sometimes try to draw this. I don't want you to draw it this way, but people will sometimes try to draw this resonance thing where the double bond is really spread in 2 different locations with like a dashed line. So the reality of what resonance is if one picture does not truly do justice for the molecule is really a blend of those individual resonance structures. One resonance structure does not do justice for the overall molecule. So how will you know that you have to do resonance? Well, if it looks like you need to swipe and share, and it looks like you have two absolutely identical choices, then you need to draw a picture doing the swipe and share from each individual choice and draw a double-headed arrow in between them. Let's do another example. What if I gave you the carbonate ion, CO3 with a 2 minus? We have a carbon and we have an oxygen. Step 1 says tally up those valence electrons. Carbon has 4 valence electrons plus each oxygen atom, and I have 3, has 6 valence electrons. And we have 2 extra electrons to play with in our picture because we have a -2 charge. So I'm going to add 2 more to this. 18 and 2 make 20 plus 4. We have a total of 24 electrons we get to play with in our picture. Step 1 says we add them up. Okay. Step 2, put the different one in the middle and connect single bonds. So we're going to put carbon in the middle, connect an oxygen, and an oxygen. We just used up 2, 4, 6 electrons. 24 minus 6 is 18. Step 3, fill in the octets of the outer atoms. 2, 4, 6, 8, 10, 12, 14, 16, 18. I'm going to take away 18. I have none left. Leftovers go in the middle. I don't have leftovers. Then check. Does your center have its 8? Does the center have an octet? The answer is no. In order to get an octet on our center, we need to swipe and share. But we only need to do it once. So which one do we swipe and share from? We need to draw a picture from each of those. So my first picture, I'm going to swipe and share from my left oxygen. I'm going to draw an oxygen with 2 lone pairs, a double bond to carbon, an oxygen on the top with its 3 lone pairs, and oxygen on the right with its 3 lone pairs. Then I draw a double-headed arrow, and the next picture has the double bond on the top. And then we have our other oxygen atoms. Then another double-headed arrow, and the last picture has the double bond with the oxygen on the right. And there are the resonance structures. What it is not is a molecule or an ion where we have 1 strong bond and 2 weak. Instead, we have 3 bonds that are absolutely identical. They're stronger than a single, but weaker than a double. They are like a bond and a third. That double bond is really kind of spread out in 3 different locations. I hope that helps. Take care.